So, hello everyone, my name is Kahlil, and this year I taught a class on abstract mathematics, specifically on Peano arithmetic and set theory, which I will get into in a second. So, first off, who am I? I am a student who has always loved math. I enjoy sharing that love with other students, with other teachers, and really anyone who's willing to talk about math with me. And over this last summer, the summer between senior and junior year, I took a class at Brown about specifically set theory and also Peano arithmetic. And that course really illuminated for me what I wanted to do in the future. I wanted it to be something theoretical, something with math, and really just a place where I can let my mind and imagination really work, which most people don't think of as math, but I hopefully through this presentation I might be able to convince you guys that math is a deeply creative and artful pursuit. So, my senior year rolls around, and I have a senior project to do. My sister did one, so I have to do one, because I have to and I'm not sure what I want to do. I have a few ideas. I tossed around doing AP Econ Club. Bad idea. Glad we did not go with that. And I eventually landed on teaching a class, because actually, during my sister's senior year, there was another student, I think it was Peano, who taught a class on music, and I was like, oh, I could do that before. So, I decided abstract mathematics is what I'm going to do, and that's what I'm doing. So, it's time to prepare. I have my notes from the class. They're a little bit sparse. I email my teacher from the class at Brown, and I get them to kind of give me some of their teaching notes and some of the homeworks that we did, and I start synthesizing them for myself to teach them. So, the first thing I start planning is Peano arithmetic. That's how the class went around, so I decided that's how I want to do it. Peano arithmetic is a type of number theory. It's a very basic form of number theory, where you use axioms to prove the most simple things about arithmetic. So, one of our more basic things is that any number plus 0 equals that number. That's an example of an axiom, and then from there we can prove that 0 plus any number equals that number. That's a very simple explanation of Peano arithmetic, but the reason I decided to choose that, even though it has basically no relation to set theory, is because it's a system of proofs using axioms that everyone knows the answer to all the questions already. If I ask people, does m plus n equal n plus m, that all of them will say yes, because they know the transitivity of addition. So that makes it much easier for students to see the path by which they can reach these answers by knowing the answers to the questions already. From there, I move on to ZFC, or Zermelo-Fraenkel choice set theory. It's a branch of set theory. It's one of the earliest ones. Gregor Cantor is the guy who invents set theory. And then, after him, people realize his system has a whole lot of issues. And so Zermelo and Fraenkel are two of the main people who fixed his system, essentially. Choice is not the name of one of the creators of Zermelo-Fraenkel choice set theory. It's actually one of the axioms. It's one of the weirder and more important ones, so that's why it's called ZFC. I talked to Andrew, again, to sponsor my senior project, and I start talking with him about what it's like to actually teach a class, because I've taken a lot of classes here at Griffin, but I have yet to teach one at this point. So I'm chatting with Andrew. We're doing twice a week meetings, once during lunch, and usually once later in the week, and I start planning my classes. What this looks like really is some of it is like this. These are just simple Peano arithmetic proofs where I write up a whole proof step by step, and I usually do it one or two ways because there's almost always more than one way to do a proof. And I'm just writing up those proofs, and then I'm typing up notes on how I want to teach how to do that proof. So I'm doing these classes. By the first class, I have 4 Peano classes planned and 2 set theory classes planned. And by the end of the class, I had planned 7 Peano arithmetic classes and 4 set theory classes. Now, this isn't the exact number that they took. One of those set theory classes I gave up on breaking up into different classes at the end, so it's just one very long class technically, although it didn't take one day. But even still, 4 plus 7 is 11, and there are not 11 Wednesdays in the year. So this is exactly what Andrew warned me would happen, is that you're going to plan a whole lot and you're not going to get to it. So for each of these classes, I have a big long list of things I want to get to, and for each of them, I never get to the end of that list, and I finish off the list at the end of the next one and start on a new one. So yeah, that's kind of how it went, but I'm happy with how it went anyways. here's some oddities. This is my funny slide. I spilled pizza grease on one of my proofs, and I wrote Jay Chillin on one of my proofs. So that's all there is to that. What did teaching the class look like? As you can tell, it was chaotic. I had a very motivated group of very excited people taking this class. Yeah, I'm into that. But despite it being very chaotic, all my students really wanted to understand Peano arithmetic and set theory, and they really worked hard to understand. So we start off with logic. This is the basis for Peano arithmetic and set theory. It's the language behind math, and it is hard. I'm not a logician. I find logic to be unintuitive, and lots of other people do too. But it's really important for understanding abstract math, because you can't express your ideas in symbols, and expressing them in words is meaningless. So start off with logic, get that done. From there we start on Peano, we do arithmetic, we start with addition. That's really the most basic part of Peano. From there, we move on to multiplication, and multiplication in Peano is actually very interesting. You typically think of addition as multiplication as a series of addition. So like 5 times 3 is 5 plus 5 plus 5. Peano teaches it in a way vaguely similar to like a factorial or recursion in coding, if you guys know what that is, where basically it defines 5 times 3 as 2 times 5 plus 5. And then you can redefine that 2 plus 5 as 5 times 1 plus 5 plus 5, and you can keep on going. It seems a bit self-referential, but eventually you'll get down to 0. That's where an axiom comes in, that anything times 0 is 0. And that is kind of how multiplication works in Peano arithmetic, and I just find that to be very cool. From there, we move on to set theory. We start with axioms. We prove a few things about like sets containing sets and stuff like that. And then we move on to ordinals and cardinals, which are both types of sets that have very specific rules about them. We move a little bit into natural numbers. We did a lot of natural numbers in Peano arithmetic, so I didn't want to get too deep into that, but the students seemed to enjoy that. So then we ran out of time. I had a lot more planned with cardinality specifically. That deals with the size of infinities, and there's so much cool stuff there. There's a lot of visual representations on why, for instance, all of the natural even numbers, that infinity is the same size as all of the natural numbers, period. So there's a whole lot of interesting stuff there. Didn't get to, but here we are. So, future for the class. Probably not one. If any of my students want to try to teach this next year, I totally go for it. I'll provide you with all of my notes, and I will give you any advice on how to teach it. That being said, I ran into a lot of issues with teaching this class. The first issue, I forgot how induction works. Induction is perhaps the core aspect of Peano arithmetic, and I was doing it backwards, and that makes it like self-referential, and it makes it terrible. So I pretty quickly figured out I was doing it wrong, flipped out, and that cost me about a week in my planning. Another issue I ran into was a lack of practice problems, specifically with set theory. Set theory is hard to find practice problems on and think of. Which made it tough for me to get my students practicing using the language of set theory and actually doing the problems. Another issue was it's a once-a-week class, and people forgot stuff. And I cannot blame them. You are in the middle of practicing for AP tests, finals, and all that. So this is probably not at the top of your list in terms of what to worry about. So no worries there, students, but that made it a bit tougher to keep things moving. Last of all, set theory is hard. It's just a hard subject. It's got a lot of moving parts. There's very specific rules about how you can construct things, and I wanted people to try to use logic when they could, the specific language of logic. So that was tough. But that being said, I think that the class went well, and I had a great time teaching. My final message is mostly to the juniors here, and that is, if you have a subject you're interested in, whether it's math, music, or maybe even quantum mechanics, start planning it now and give teaching it a try. If you start planning it and you're like, this is a mess, I don't want to do this, don't do it. You don't have to do it, you don't have to do a senior project. But I have found teaching this class to be one of the most rewarding things I've done here at Griffin, and it's really deepened my knowledge of set theory. It's helped me understand these concepts so much more, and a lot of the questions that my students asked were ones that I had myself when I was a student. I realized what was the thought process on those questions, and it just helped so much with getting that like through my head and understanding set theory. So, finally, questions. Anyone have questions about set theory, Peano arithmetic, abstract mathematics, or teaching a class here at Griffin?
As someone who knows nothing about any of this, what are some like applications of this? Like, who might want to know how to do this?
Very few.
Oh.
So the point of abstract mathematics is that it doesn't have an application,
Okay.
and once it becomes applicable, you get applied math, which is also very cool. It's just a bit different. I find that set theory is sometimes slightly related to coding and matrices and linear algebra, but it's very rarely. It's mostly just doing it to prove that you can and for the bonus. Then,
for someone who knows probably even less, can you very on the simplest terms explain what set theory is?
yeah, so set theory is the study of sets. Sets are collections of things. They can be collections of numbers, objects, although typically in set theory we're talking about sets of sets. They all kind of boil down to this set called the empty set. It's a set with nothing in it. So basically, it's just talking about the relationship between sets, just as math typically talks about the relationship between numbers, it's talking about the relationship between sets. How do power sets work? A power set is the set of all subsets of a set. And a subset is a set whose elements are contained within a set. So a power set is basically every combination of elements within a set. Wes?
Now,
Yes,
how could
bud?
I get to the empty set
How do you get to the empty set?
without being told which number is it, or which set, or which element has an empty set?
So the typical way of constructing the empty set is from two axioms. There's the axiom of existence and the axiom of schema of separation. Axiom of existence says that a set exists. You take that and you apply the axiom of schema of separation, which says you can remove sets from a set and it remains a set. You combine these to take a set that exists and remove all the sets from it, and then you have the empty set. That's the basic proof for the existence of the empty set. Kyle?
Do you have interest in teaching in the future?
I would love to. My current kind of path, like dream path, would be math, PhD, maybe physics PhD, go on to teach, work in academia, maybe research. Is that what will end up happening? I don't know. But I would certainly like to continue to teach in the future. I loved teaching this class.
Was there ever like a point where you were teaching and like somebody asked you a question and you just like did not know the answer?
Yes, very much. So one of the specific ones is a set cannot contain itself, but there's a question, can a set contain a set that contains the first set? So it's like A contains B and then B contains A. That can't happen. I knew it couldn't happen, but I didn't know why. So I went home, I did some research on it, I constructed some sets, some hypothetical sets, and I eventually wrote up a proof for why it couldn't exist. I came back to my students and said, this is why. There were a couple times when they asked questions and I couldn't figure it out, and in that case, I emailed my teacher from Brown over the summer, and they were super helpful and willing to answer my questions, so that was also really nice.
How do you think teaching your peers differs from teaching from a position of authority?
I had to wrangle them more. Classroom got crazy. It got a bit loud at times. I had Valeria in there with me a lot of the time, which was helpful. It was much more relaxed than a typical class, which was good and bad. It let the students kind of play in the space and have fun, but it did pose some issues with cracking the whip, so to say. Torin.
Can you explain the universal set?
Okay, so there is not a universal set. In Miller-Frankel choice set theory, there is a concept called a class, and a class is essentially like a set, but it doesn't have the rules of a set. And the universal class is just everything. So it's literally just everything. That's what the universe is. Charlie.
Yeah.
You want me to explain big union? These are all different aspects of set theory. Union, you basically take two sets, you put them together, that's a new set.
No, but can you explain it to how you explained it to us?
No, we're not doing the union joke. I made a whole joke about unions where I like explained the history of unions and we're like, oh, that's wrong notes. I'm talking about the history of like unions, like work unions, not unions in that.
Is there like a particular moment where you like had like found your passion about like a teacher or something, or was it like mostly by yourself?
I've just always had good math teachers, if I'm being honest. I've been good at it, and then in middle school I had this teacher, Miss K, who was great, and then I had obviously Ashley for my 4 years here, and she was awesome. So that was a big influence. And then my teacher at Brown over the summer really like outlined what it would be to be a math major and explained the courses you'll probably take and where you can go from there, and that sounded really interesting to me too. So those were the two kind of three big aspects. Henry.
How did you grade your students?
So I did have a point system where I would subtract points if they were being bad in my class. Never actually came to grading. I gave them 100s if they tried, and they all tried. So good job, everyone. Any other questions or? Sweet, thank you guys for coming out.